Section 3 of Chapter 15 deals with the different types of landform that result from a glacier. The first term you need to get down is a moraine, and this is a landform made from glacial till, and typically they're ridges of unsorted rock material on the ground or on the glacier. And one of the things that's important to get down there is that the fact that the material is unsorted, and what that means is you can have anything from boulders and big rocks or erratics, a term we'll see in a little bit, down to the glacial till or the sand type material. First type of moraine you'll encounter is a lateral moraine, and this typically is strips of dirt and rock that flow with the ice along the sides of a valley glacier. And what they look like in this illustration here, at one time there was a lot more, ice in this area, and along the edges here, we could even say there are some lateral moraines along the edges, along the sides of a valley glacier. Medial moraines, just like the median in a highway, medial moraines tend to occur in the middle or within the glacier. When a segment of the glacier merges into a larger ice mass, lateral moraines create debris in the middle of the larger flow. And if you think about like a bulldozer pushing it, where two bulldozers would come together, or two glaciers come together, they're going to form a medial moraine down the middle. And as illustrated here, these are medial moraines here and here, and then this big one, you can see it all the way back up here. Medial moraines down the middle of the glacier. Continental glacier, the landforms, they erode by leveling existing landforms, and they produce relatively smooth, rounded landscapes. You got to think that a continental glacier, as the term implies, is a lot bigger, covering an entire landmass instead of just one valley. The features are exposed as the glacier retreats because you can't see the underlying features until the ice melts away. This photo illustrates a moraine, and again, they're made from glacial till, and you notice that a lot of this material, different sizes, it's not sorted by the size right here. I would describe this as a terminal moraine, or at the terminus, and I'm thinking that a glacier probably, as you can see here, traveled down and formed this valley, and then it pushed up this material in the foreground of the picture into a terminal moraine. And again, these are ridges of unsorted rock material on the ground or on the glacier. Ground moraine, again, is a mantle of till deposited underneath the ice, and they're often pretty rocky. There wasn't any water flowing underneath the ice, and you need that water flow to sort the material. This is typically just as the glacier retreated or receded, it left back this bigger material. And again, if you think of that bulldozer pushing it down this mountain, as the glacier retreated and melted back, it left all of this material in the foreground of the picture. Another example of ground moraine is here in this picture, illustrates Ohio, Montana, Wisconsin, Michigan. A lot of that ground was pushed down from Canada, and farmers and people putting in a new yard and cover the rock deposited from the last ice age. Like I said initially, a lot of the material, the topsoil, we can thank Canada for, because the glaciers pushed it down into northern and especially southern Wisconsin at the terminus, or the bottom of the last glacial age. Terminal moraine, then, you can call it an end moraine. It's at the end of the moraine, and typically these are hilly ridges composed of a mixture of rock, sand, and clay, and marks the farthest advance of the ice. In this picture here of this glacier, here's the terminal moraine at the end of the moraine, as far as, consider this a bulldozer blade, as far as it had pushed down. Cape Cod and Long Islands are examples of terminal moraines. When the glaciers pushed down in that part of New York, it formed those islands, and that was as far as the glaciers advanced in that area. Till. What is till? This is a result of glacial drift. And typically till contains various sizes of sediment that's not sorted or layer. And in the graphic here of till, you can see that it's poorly sorted, angular, pebbly, bouldery, clayey, sandy, no regular bedding planes. There may be striations, which are scratches caused in the bedrock, but it isn't organized into classes, different classes. It's all mixed up. Outwash, on the other hand, is glacial till that has been transported, sorted, and deposited by glacial meltwater. Again, where there was water, the water either under the glacier or at the terminus of the glacier sorted this material. And you can see here that we've got different varieties of clay. It's well sorted and cross-bedded. Cross-bedded means that it formed these different beds. We've got it organized by the weight of the material, pebbly sand, and then finally the rounded pebbles on top of the bedrock. A cane. When you travel, and you can see that this picture came from one of my professors at the University of Wisconsin, Professor, a cane are small hills of sand and gravel formed from outwash. So it means that this material was sorted, and there are a few that you can still see some of these when you travel. Say you're traveling Highway 41 from Green Bay to Milwaukee. If you look to the east or west of Highway 41, you can still see some of these cames, although because of their material, and if you look at here, the material is well sorted. Engineers, geologists, mining companies, you can see sand and gravel operations like this material for gravel. Makes good gravel. An esker is a narrow ridge of sand and gravel in the middle of a ground moraine, and they'll wind for kilometers roughly parallel to the direction the ice moved. They form from meltwater, streams that flow in tunnels. If you remember from the video we watched on the first day when I introduced glaciers, the geologists or glaciologists were inside those tunnels, and typically there, because the water's flowing, it's going to form an esker. This is an esker here that formed in Keyser Pond in Maine. Personal note, I have a log cabin in northern Wisconsin where my brother and dad and I built, and it sits on top of an esker. A lot of the material, the rocks that we put into the fireplace came from the base of the esker, and a lot of the sand that we used to mix the mortar, the chinking, came from the base of this esker. I can go there to this day and dig out, if I'm looking for sand, gravel, rocks, I can get it out of that esker. Again, gravel pits. Today, cames and eskers created during the last age are frequently exploited or used as gravel pits. We've got several of them, small ones on the property that I mentioned. The esker that when we built the cabin there, we knew we'd have good gravel at the base of that esker. And again, you can see that this came, the material is sorted. You can see the different layers here. Typically the boulders Boulder's a bigger rock, and they're rounded. They're nice, call them fireplace rock, because they've been rounded by the glacier as they've been transported by the glacier. Erratic. If you've ever been in the woods in northern Wisconsin and you come across a big boulder sitting all by itself, this was typically transported by a glacier, and it's may not be part of any of the existing bedrock. It was transported or carried by the glacier. You know, if you look for scale here, we've got guys standing in the foreground, and this is a pretty big erratic or boulder that was transported by a glacier. Typically it's a different rock type too, because like I say, it's been moved. A lot of our erratics in northern Wisconsin come from Canada, of course, from the Canadian shield deposits, and they're not the same rock as is underneath the erratics. A kettle lake is a result of a very large block of ice that was left behind as the glacier receded or moved back. And the melting ice forms potholes, which are sometimes filled with water in a glacier. They have till or outwash in them, and vegetation may grow up around them. And a lot of times these lakes, you can still see some of these. And again, if you travel the Kettle Moraine district of southern Wisconsin, in between about Fond du Lac, if you look to the left and right, and some of those smaller pothole lakes, they still exist, but a lot of those are drying up because, again, they're not getting their water from either a spring or groundwater. They sit above the groundwater, and they are going to dry up or fill in with vegetation. A drumlin is a long, low, tear-shaped mound of till, and the long axes of the drumlins are parallel to the direction of the glacial movement. A lot of times they have the shape of an inverted spoon, and again, these are some pictures that I got from an old professor of mine when I took a glaciology class at Madison. And what we mean by it, that the long axes are parallel to the direction of the glacial movement. I don't know which direction is north or south here, but you can see that, you know, that the glacier that carved this was moving in, let's see, probably moving in this direction. This is probably south towards the top of the picture, because as the glacier moved and receded, again, you think of a bulldozer, the ice retreated or melted back in this direction to form that long tear-shaped hill. And again, you travel that Highway 41, you can still see, I can point out some of these drumlins to you. Roche Montagne, good old French term here. These are rounded knobs of rock created by a glacier. The glacier polishes and smooths out the tops of the existing rocks as it passes over. The glacier will, like, pluck, we call it, chunks of the rock out as it passes by, creating a rough surface on the side. Again, here's something put in the picture for scale. These scratches on top of this rock were caused by the glacier dragging over the top of it, and you can see that as it moved, it pulled out chunks of material on the sides and on the front of this Roche Montagne. The dangers associated with glaciers, as the video on the first day when we introduced this subject, because they're moving at different rates, you can get crevasses that form. You know, here's this illustration here, crevasse, here's some more crevasses, which are cracks. A lot of times they may be open up at the top, but they can be smaller at the bottom. If you fall into one, you know, over time, you'll probably become part of that glacier as it moves over the top of you. A lot of, like, the cavemen that we've recovered is the fact that they fell into a crevasse and got trapped in the ice. Icebergs, they occur typically at the terminus when a glacier meets the ocean, and they calve, and the parts of the glacier break off and float out to sea. Pieces of an iceberg again is a piece of ice that breaks off of a glacier. Greenland is typical of icebergs, where a lot of them come from in the North Atlantic, and of course in the South Atlantic. Pacific, we have Antarctica. Ice sheet on Greenland is a primary source of icebergs in North Atlantic, and create a hazard for ships, as the video pointed out that what you see is usually only about 10% of the whole iceberg. And again, a lot of them have this nice blue color because the air has been squeezed out of the ice. Crevasse again, that large crack formed on the surface of a glacier. A lot of times they're covered with snow and can extend as much as 30 meters down. And this concludes the lecture notes for section 3 of chapter 15.